Hi, Limno folks. This is Gabe Cap, and the case study I ended up landing on is called Rapid Response for Invasive Water Weeds at the Arctic Invasion Front, Assessment of Collateral Impacts from Herbicide Treatments. I subtitled that Alaska's Elodea Problem. So let me just talk a little bit about elodea, and then I'll get into what the case study was actually about. So elodea is a freshwater macrophyte. Um, it's invasive to Alaska. It was first found in 1982 in Eyak Lake in Cordova, and it has spread throughout Alaska. So, elodea is a really hardy plant and particularly prolific. You can sort of see this graphic here. Uh, it comes in and it just sort of mats up and really just blocks out all the native macrophytes. Um, it also doesn't go dormant during winter. You can see this here. It'll continue to grow under the ice while other macrophytes will kind of go dormant. So it's a particularly aggressive species, and just chopping it up doesn't really kill it. Chopping it up just makes it grow more. They reproduce vegetatively, so like machines chopping them up doesn't really do much. They've also talked about potentially introducing herbivorous fish, but nobody really wants to introduce non-native fish to control them because that's just another invasive species. So they're looking at using herbicides to kill this plant. So here you can kind of see some modes of transportation for how they think the spread is going. You can kind of see this map over here. This is the flight paths for float planes. Actually, Eyak Lake is a huge float plane lake, and you can see all just the mats of grass. I don't know if that's actually elodea or not, but this was kind of what elodea would look like. This is elodea here on this propeller, so it's getting transported all over, through boats and float planes. Um, that's just kind of the invasion path for this plant. So as far as this study goes, the point of the study is to try and evaluate the ecological benefits and risks of using a herbicide to treat the lakes, and just sort of see the impact on zooplankton and macrophytes, and just see if it'll actually kill the elodea, and just sort of see the ecological impacts. So this is a map of just sort of the location, the Kenai Peninsula, kind of down here by the star, and then they have 4 different lakes that they're using to sort of test this out. They have 2 lakes that are treated, Daniels Lake and Beck Lake, and then they have 2 lakes that are going to be untreated, sort of reference lakes or control lakes, Island Lake and Douglas Lake. Daniels Lake has was patchy, has patchy elodea. I guess they have like 5 distinct patches of elodea, and Beck Lake is like heavily infiltrated. Like the whole littoral zone is just thick with elodea. So how they're gonna go about evaluating things is they're gonna use this herbicide, fluoridone. Um, they're gonna treat the lakes with it, I guess, in quantities of greater than 8 parts per billion. It effectively kills the elodea. I guess it takes about 2 to 3 months for the treatment to be effective. So over the course of time, they're gonna monitor it. They monitored and made sure that the herbicide was between 6 and 8 parts per billion for the duration of the treatment. They did different monitorings. They took water quality samples weekly, and they did zooplankton tows monthly to see how the treatment might be affecting their production. And then They did some macrophyte tows to see, how much the elodea was going down and what other kind of macrophytes are in there and growing. Fluoridine is a photosynthesis disruptor. It's taken up by the elodea through the shoots and roots. It's EPA approved, and the chemical decreases with sunlight, or I guess it degrades. It can also be absorbed into the soil and degrade therein. So here are some of the results for their water quality on the samples that they took. Looks like they measured dissolved oxygen, pH, chlorophyll, conductivity, and Secchi depth. Basically, they found out that water quality was not really affected by the treatment. The treated lakes tended to have lower clarity and higher chlorophyll A. Other variables in the season just had a more impact on water quality. So for zooplankton, they found really no taxonomic difference in richness across the infested and treated lakes and the uninfested and untreated lakes. In fact, Daniels Lakes, one of the treated lakes, had the highest richness in zooplankton, and Douglas Lake, one of the untreated, uninfested lakes, had the lowest richness. So other variables were more important in zooplankton richness than the fluoridone treatment. As for macrophytes, pretty much the same thing. There was little impact on the native macrophytes, except for you can see this lily, water lily here. There was a increased senescence over the period of treatment, but that senescence also occurred at the untreated lakes just later in the summer season. They used rake sampling to calculate the decline of elodea over the 2 years. You can see the black line is 2014. It goes down pretty significantly, and then by 2015 it's pretty much at zero. And then they did one sample in 2016 and they couldn't find anything, so they knew that they had completely eradicated the elodea. Okay, so here you have a graph of the native macrophyte growth over the 2 years, and you can see how there's uh, growth for all the lakes. In the first in 2014, like the red is Back Lake. It looks like it's about 1.5 at day 175 right here, and then if you go to day 175 for 2015, it's up over 2-ish. And I guess I should also mention that these numbers 0, 1, 2, and 3, it's just a visual cue. Like when they sample with the rakes, they have pictures that they look at, and they'll like look at the fullness of the rake and they'll rate it 1 to 3. But you can see that over the course of the 2 years that the fullness does go up for the native plants. So we saw that the fluoridone treatment had little effect on diversity of macrophytes and zooplankton. It didn't really affect their taxonomic richness, but they didn't collect any samples on benthic macroinvertebrates or other fish. It's actually sort of why I'm interested in this subject right now. I'm sort of hoping to find work studying elodea removal and how it's affecting salmon smolt this summer. So that'll be cool if I get that job. But so yeah, that's what's next. How does it affect the fish? It doesn't seem to be harming anything else too much, so hopefully it's not affecting the fish much at all either. But time will tell. I'm kind of excited to find out. And here is the bibliography. This is the end of my presentation. Thank you all for listening. I appreciate your time.